Okay, so collision theory, which assumes that the reactant molecules, they collide with energy greater than, they collide with an energy greater than some minimum value and proper orientation. So there are two things important: orientation, right, and some proper value. Orientation of collision is very important, all right, and whatever the minimum energy is required for this collision is called activation energy, and we call EA, activation energy. Alright, and we will explore temperature, effect of temperature, alright, on that collision. So we will explore the effect of temperature and which increase on each of the three requirements. I'm going to explain what are the three requirements. For a reaction to occur. So the rate constant K is given by ZFP. Now what is that? K is a rate constant. Z is a collision frequency. P is orientation factor. Orientation factor. And F is fraction of collision with minimum energy. Fraction of collision with minimum energy. With minimum energy. So what happened if Z increase, let's say the frequency Z increase with temperature, right? So average molecule, so temperature affects with collision frequency, right? So what happened when we modify this equation? The fraction of molecular collision having minimum energy required is given by F. So when we write EA divided by RT, let me rewrite that, and 1 over E raised to EA divided by RT. So we can see the impact, the fraction of collision having a minimum energy increase exponentially with temperature. So what happened? The reaction rate depends on P is what? Proper orientation. Orientation for the collision. And this factor is independent of temperature. This factor is independent of temperature. So collision factor is important. So I'm going to explain what are the importance of molecular orientation with one example, NO and Cl2 when they react. I'm trying to draw that and then see if you guys can follow it. So let's go to next one. Let's say if we have this is NO molecule and we have Cl2 molecules, okay? When they are in certain orientation, let me draw it again. Let's say this side is N and this side is O, and then it is Cl and Cl. When they are in proper orientation, this side of the Cl, this side of N, they are in proper orientation. That's where the reaction happens. This is O side, this is N side, and this is Cl side, another Cl left. So that makes this is O, N, and Cl. And that's where reaction happens. But let's say, for example, if it is other way around, this side is N side, this side is O side, and when you have 2 chlorine, and this chlorine and reacts with oxygen, there is nothing happen, no reaction happen. What that means? Orientation. Orientation. If they orient in this way, closer chlorine is closer to N, then its reaction happens. But if it is other way around, it does not affect. So that means molecular orientation affects on collision.